Hello, curious minds. Welcome back to ProjexCellence ProDigy, your one-stop solution for all your project management and engineering learning needs. I am Govind, PMP Certified Project Manager. And today, we are starting a very important engineering foundation topic. Basic terminology or nomenclature of reciprocating internal combustion engines. If you are a mechanical engineering student, a fresh graduate, or someone who has just entered the industry, you will often hear words like bore, stroke, compression ratio, TDC, BDC, displacement. Many engineers use these terms without fully visualizing what is actually happening inside the engine. So today, we will simplify all these terms step by step using practical examples. Let us begin with the most fundamental term, bore, also called cylinder diameter. Bore is simply the inside diameter of the engine cylinder. If you look at the cylinder from the top, you will see a circular opening. And that diameter is called the bore and is usually represented by small d or capital D. In simple words, bore tells us how wide is the cylinder from inside. And this is the space in which the piston moves up and down. Bore plays a critical role in engine performance because the piston and the piston rings are designed to match this diameter very precisely. And when this fit is correct, we get proper sealing, good compression, efficient combustion, and smooth engine operation. During actual engine operation, over the time, the inner surface of the cylinder does not remain perfect. It starts wearing out. And this wear normally happens due to continuous rubbing of piston rings, high temperature and pressure, lubrication issues between piston and liner, dust or contaminants, and side thrust of the piston. As a result, the cylinder diameter gradually increases. And this wear is not uniform. Usually, more wear happens near the top, here, and on thrust sides, and in the piston ring travel zone. So the cylinder may become oversized, oval in shape, or tapered from top to bottom. So during engine overhauling, we check diameter reading and ovality. Normally, bore gauge is used to measure the bore diameter. Every engine manufacturer gives a maximum allowable bore limit. If the bore reading we get within limit, cylinder can continue in service. And if it is beyond limit, cylinder liner must be replaced. Because beyond this limit, the piston rings cannot seal properly anymore. It will lead the blow-by, means combustion gases leak past the piston rings into the crankcase. Also, it may lead to high lube oil consumption. Oil starts entering the combustion chamber and burns. Excessive wear may damage the piston rings or even piston, and it may create the liner scoring or major engine failure. So bore is not just a dimension, it is critical parameter for engine health. And that's why during major overhauling, bore measurement is mandatory. Next is TDC, top dead center. This is the highest position reached by the piston inside the cylinder. At this point, the piston is very close to the cylinder head. It cannot move any further upward, and it is just about to change direction and move downward. At this position, piston is far from the crankshaft. The crankshaft and connecting rod are almost in a straight line. At TDC, the cylinder has the smallest volume. This small remaining space above the piston is called clearance volume. Combustion happens near TDC, and in real engines, it is mostly just before TDC. In petrol engines, spark is given slightly before TDC because combustion takes time. In diesel engines, fuel is injected just before TDC and it auto ignites due to high temperature. Bottom dead center, BDC. This is the lowest position reached by the piston inside the cylinder. At this point, the piston is farthest from the cylinder head. It has completed its downward movement and it momentarily stops and changes direction from downward to upward. Here, the distance between piston and crankshaft center is minimum. That's why piston is closest to the crankshaft at BDC. And if we see here, the space above the piston is maximum. This includes both swept volume and clearance volume. So BDC represents the largest volume inside the cylinder. Next is stroke, also called piston travel distance. Stroke is the linear distance traveled by the piston inside the cylinder between TDC and BDC, and it is represented by capital L. When the piston moves from top to bottom, it travels a certain distance. And when it moves back from bottom to top, it travels the same distance again. So this one-way distance is called the stroke. Stroke is directly related to the crank radius, R. Stroke L is equal to 2 into crank radius. Why? Because when the crankshaft rotates from top position to bottom position, that is 180-degree rotation and the piston completes one full stroke. Engine capacity depends on stroke. Along with bore, stroke decides how much volume the engine can handle. Larger stroke means larger displacement, more power potential. In long stroke engine, they have higher torque and lower speed. And in short stroke engines, they have high speed but lower torque. So that's why heavy engines like marine or power plant engines use long stroke and cars and racing engines prefer shorter stroke. Clearance volume, we represent it with VC. Clearance volume is the small volume remaining above the piston when the piston is at TDC, top dead center. This space forms the combustion chamber. If no space remained at the top, the piston would hit the cylinder head and there would be no room for compressed air or air-fuel mixture. So this small space is absolutely essential for engine operation. Compression ratio. It is represented with small r. Compression ratio is the ratio of total cylinder volume at BDC to clearance volume at TDC. Means Vs plus Vc divided by Vc, where Vs is swept volume and Vc is clearance volume. Compression ratio tells us how many times the air or air-fuel mixture is compressed. If suppose compression ratio is 10:1, it means the volume at BDC is 10 times the volume at TDC. The air or air-fuel mixture is compressed into 1/10 of its original volume. Compression ratio directly affects pressure, temperature, combustion quality, engine power, and fuel efficiency. So generally, high compression ratio means better performance. But there is a limit. If compression ratio becomes too high, in case of petrol engine, there may be knocking or there is a risk of engine damage. Even in diesel engines, it may lead to higher mechanical stress and higher temperature. So it must be within design limits. Normally, petrol engines compression ratio is in the range of 8:1 to 12:1. And diesel engine compression ratio is much higher, which is in the range of 14:1 to 25:1. Next term is swept volume or displacement. Swept volume is the volume covered by the piston when it moves from TDC to BDC, and it is represented by Vs. And to calculate Vs, the formula is pi by 4 d square into L, where d is the bore diameter and L is stroke. So basically, swept volume is cylinder area into stroke length. Swept volume tells us how big the engine is. It directly affects engine capacity, air intake, fuel burning, and power potential. Normally, when we say 125cc bike or 150cc bike or 2000cc car or 2-liter car, we are referring to engine displacement or swept volume. And cc here means cubic centimeter. In a single cylinder engine, swept volume will be Vs. But in a multi-cylinder engine, the total displacement or swept volume will be Vs into number of cylinders. For example, if one cylinder is 500cc and there are total 4 cylinders, so total engine capacity will be 2000cc or 2-liter engine. That's why cars are often described in liter, 2-liter car. Piston speed. Piston speed is the average linear speed at which the piston moves inside the cylinder. Since the piston keeps moving from TDC to BDC and then from BDC back to TDC, its motion is reciprocating. So piston speed tells us how fast the piston is traveling up and down inside the cylinder. And we can calculate the mean piston speed with the formula 2 into L into N, where L is stroke in meter and N is revolution per second. Suppose stroke is 0.3 meter and speed is 1000 rpm. So we can calculate the piston speed with this formula 2 into L into N. So it will be 2 into 0.3 into 1000 divided by 60. Because revolution we have to take in revolution per second RPS. So it will come 10 meter per second. So piston mean speed is 10 meter per second. So to summarize today's lesson, bore defines the cylinder diameter. Stroke defines piston travel distance. TDC and BDC define piston positions. Clearance volume and swept volume define cylinder capacity. And compression ratio defines how strongly the mixture is compressed. Once you understand these basic terminologies, reading OEM manuals, performance charts, and technical drawings becomes much easier, especially when you step into real industrial environments. If you found this lesson helpful, don't forget to like, subscribe, and share ProjexCellence ProDigy. Your support motivates me to create more simplified engineering and project management content. Namaste, goodbye, Sampai Jumpa.